Today you will be looking at arithmetic sequences and series. So the definition of arithmetic sequence. If a sequence is arithmetic, the differences between consecutive terms are the same. So if I have a sequence a1 all the way through the nth term, if there is a number d such that a2 minus a1 is going to equal the third term minus the second, the fourth minus the third, etc., and it all equals the same number, that number d is what's referred to as the common difference. So in our first type of problem, we're just going to decide whether each sequence is arithmetic. So if it helps you, what you can do here is you can label each of your terms a1, a2, a3, a4, a5, etc. And we know that if we take a2 minus a1, or 1 minus negative 3, we do get 4. If we take a3 minus a2, 5 minus 1 is 4. a4 minus a3, 9 minus 5 is 4. And 13 minus 9 is 4. So because we have the same difference, we say, yes, it's arithmetic. Common difference is 4. If we look at letter B, we're going to set it up very similar. A1, A2, A3 is 10, A4 is 17, A5 is 26. So 5 minus 2 we know is 3. 10 minus 5 is 5. So because those differences are not the same, we cannot say that it is arithmetic. So this one is not. Okay, next one. For the general term of an arithmetic sequence, the nth term of an arithmetic sequence with the first term is a1 and common difference d is given by this formula a sub n equals a1 plus n minus 1 times the common difference. That is the formula that you need to know. So if we look at our next problem, we're going to write a rule for the nth term of the sequence, and then we're going to find the 20th term. Okay, so the first thing that we will do is we will identify a1, so a1 is 50. In our common difference, notice we are decreasing for each consecutive term, and it looks like we're decreasing by 6, so negative 6 is our common difference. Next thing we'll do is we'll write our rule for the nth term. A sub n equals a1 plus parentheses n minus 1 close times the common difference d. So here we go. an equals 50 plus parenthesis n minus 1 close parenthesis times negative 6. And all that's left for us to do is to clean it up. So we'll distribute the 6 through the parentheses. Okay, so a sub n equals 50 minus 6n plus 6. And then we just add like terms. A sub n equals 56 minus 6n. So that's our rule for the nth term. That is one of our answers. And now we have to find a sub 20. So a sub 20 is equal to 56 minus 6 times 20. So 56 minus 120 is negative 64. And that's it. So if we look at the next problem, this time we're going to write the first 5 terms of the arithmetic sequence, with the 20th term being negative 111 and the common difference negative 6. So the first thing we're going to do is we're going to write a rule for the nth term. So we know we have a sub n equals a1 plus n minus 1 in parentheses times the common difference. Now this time, because we have an ending term, we know the negative 111 is the an, the 20 is the n, and the difference is negative 6. And we just substitute those values in. Negative 111 equals a1 plus 20 minus 1 times the common difference, negative 6. Okay, so negative 111 equals a1. 20 minus 1 is 19, times negative 6 is, I believe, negative 114. And then to solve for a1, you would add 114 to both sides and you do get a1 equals 3. So that's the first step. The next step is to write the first 5 terms of the sequence. Okay, so you could write the rule for the nth term if you want to. It is good practice. And if you wanted to clean it up, you could. Or we know a1 is going to be 3, we've already found. a2, you just type 3 plus 3 minus 1 times negative 6. Okay, and then we go type it into a calculator. Should be negative 3. To find a3, we'll do the same thing. 3 plus, I made a boo-boo. That should be a 2. 3 plus 3 minus 1 times negative 6 would be negative 9. A4, 3 plus 4 minus 1 times negative 6. Let's see, negative 15. And then the 5th term. Okay, now I would like you to take a minute or two and try the example you try. So hopefully on this example you try, you found the first term to be 13. Your rule for the nth term, a sub n equals 13 plus, in parentheses, n minus 1 times negative 4, and therefore your second term is 9, third term 5, fourth term 1, and fifth term negative 3. So in this next problem, you're going to find the arithmetic sequence. This time you're going to be given the 6th term and the 10th term. And with this type of question, there's a couple different things that you can do. First of all, I know the 6th term, and I know the 10th term, right? I know the 6th term is 10 and the 10th term is 22. When you're looking at these problems, I want you to think of in your mind, later equals earlier plus number of steps times the common difference. So if we look here, the number of steps that we have from 10, 1, 2, 3, 4. So we have 4 steps. So when we write our rule for the nth term, we're going to start with our later, earlier. So our later is 22 equals our earlier 10 plus our number of steps, which is 4 times the common difference. So when we'll subtract 10, 12 equals 4d, or d is going to equal 3. Once we can do that, now we can find our rule for our nth term. Okay, so if I know we have an equals a1 plus n minus 1 times the common difference, and it doesn't matter which one you choose. You can choose a6 or you can choose a10 to plug in. If we choose a6, that means n is 6 and an is 10. 10 equals a1 plus 6 minus 1 times our common difference, 3, and we'll solve for a1. 10 equals a1 plus 15, so a1 here is equal to negative 5. Okay, and then our rule for the nth term, we will plug in our values for the common difference in a1. So a1 was negative 5, common difference is 3. So an equals negative 5 plus 3n minus 3, or our final answer, an equals negative 8 plus 3n. Okay? Take a minute and try this example you try. So hopefully you found a common difference to be 4, the first term to be 10, and the rule for the nth term to be 6 plus 4n. Yay, it's time to practice. The end.